Hello and welcome back to Math with Mrs. Becker. Today in Algebra 2, we are going to finish up our notes from section 6.2, part 1. If you remember, the last time we were together, we did have a shortened class period, so we were unable to make it all the way through the notes in the time that we had. So today we are going to pick it up right where we left off. As a reminder, we are currently multiplying polynomials. The first thing we want to see today is that you can multiply polynomials that have an exponent. This exponent tells you how many times you have this binomial. So for example, a plus 2b to the power of 3 really means that you have a plus 2b, you have that 3 times. Now when you multiply, remember you can only multiply two things together at a time. So what I'm going to do is multiply these two binomials together. I will just carry down the a plus 2b. Because this is 2 terms by 2 terms, I can use the FOIL method. A times a would be a squared. A times 2b would be 2ab. And again, notice when you have a term that contains more than one variable, you have to make sure that the variables are written in alphabetical order, which is why the a came before the b. When I multiply the middle, 2b times a is 2. Again, the a would have to come before the b. Finally, 2b times 2b, 2 times 2 is 4. This has a b, this has a b, so together it's b squared. Again, I'm just going to rewrite my first a plus 2b. I want to make sure that I don't forget about it. The middle two terms are like terms because they contain the exact same variables. They both have one a and one b. So I can combine them, giving me 4ab plus 4b squared. Now we are right back to the skill that we were just practicing. A has to go into the entire second group. A squared plus 4ab plus 4b squared. Then positive 2b has to go into the entire second group. That is one thing that I like with this section. They will slowly but surely add additional steps. Like here you had a power of 3, so you had to write 3. Then you went ahead and multiplied. But what happens is it brings you right back to a skill that we just learned. So yes, we just practiced something new, but now, as long as you remember what we did on our last video, you're ready to roll. Now I'm going to bring one a into each of these terms. This had 2 a's. When I give it another one, now it's 3. This had 1 a, so now it would be a squared b. This term did not have an a, so it would have ab squared. Now when I bring this in, I'm going to multiply every number by 2 and give every term an additional b. This has an unwritten 1, so 2 times 1 is 2. I would have 2 a's and a b. 2 times 4 is 8. I have 1 a, this has a b, this has a b, so now it's b squared. 2 times 4 is 8. This has a b, this has 2, so together there's 3. Now remember when you're writing your final answer, there is no standard form for this problem because I do have 2 variables, but we do need to make sure that we combine like terms. So when that happens, what I do is I just go in order of the problem. The first term has 3 a's. I do not see any other terms that contain a cubed, so I'm going to write that first. The next term has 2 a's and a b. Hey, look at that. This term also has 2 a's and a b. These are like terms, I can add them together. 4a squared b plus 2a squared b, that's 6a squared b. This term has 1a and 2 b's. This term has 1a and 2 b's, so I can combine them. 4 plus 8 is 12ab squared. And last but not least, I do have one term that has b cubed. That would be my final answer. And again, this could be in any order. So if you had 8b cubed plus 6a squared b plus a cubed plus 12ab squared, kudos to you, you're a rock star. That's still correct. Okay, let's look at another one. This time we have a power of 4. Holy smokes. So if I have a power of 4, I have x plus 4 1 time, 2 times, 3 times, and 4 times. Now remember, you are only allowed to multiply 2 things together at a time. So I could multiply those 2 things together, then multiply those 2 things together, then take those 2 products and multiply those together. This is getting wild. So if I go x times x, that's x squared. X times 4, that's 4x. 4 times x is 4x. 4 times 4 is 16. I can combine the middle two terms. So x squared plus 4x makes 8x plus 16. Now I could go ahead and do this again, or I could look and say, all right, when I multiplied x plus 4 by x plus 4, I ended up with a trinomial x squared plus 8x plus 16. Well, notice this is the same exact thing. X plus 4 times x plus 4. So I'm trusting my math enough to think, okay, the first time I multiplied these together, I feel like I probably got that correct. So knowing that I'm multiplying the same thing, I just rewrote that again, assuming that this product would be the same. Now we are back to the last skill that we practiced. X squared needs to be brought into x squared plus 8x plus 16. Then 8x needs to be brought into x squared plus 8x plus 16. Then 16 needs to be brought into x squared plus 8x plus 16. So one term at a time, we are going to go ahead and distribute. The first thing that I'm bringing in is x squared. So every term gets 2 more x's. This had 2 x's, so now it would have 4. This had 1 x. If I give it 2 more, now it has 3. 16 did not contain a variable, so now it is 16x squared. Now the next time I bring in 8 and an additional x. So this becomes 8x cubed. 8 times 8 is 64. 1x and 1x makes 2 x's. 8 times 16 is 128. This has an x, this does not, so together it's 1. Now I go ahead and multiply in 16. 16 times x squared is 16x squared. 16 times 8 is 128. This does not have an x, this does. Plus 16 times 16, when I bring that here, that's 256. Your final answer, this time there is standard form because I only have one variable. So I need to make sure that my final answer goes from the highest exponent on that variable to the least. And in the process of doing that, I need to make sure I combine like terms. X to the power of 4 would go first because that's the highest exponent. This term has x cubed. This term has x cubed. So I can add them together. 8 plus 8 would give me 16 x cubes. Now x squared, 16, 64, and 16. If I take 16 plus 64 plus 16, I would have 96 x squareds. X's, 128x plus 128x is 256x. At the end, I have a constant of 256. This would be your final answer. And again, it's standard form because I have 4 x's, 3 x's, 2 x's, 1 x's, no x's. Kind of fun stuff. Yes, it's a little bit time consuming, but it's kind of fun. Let's go ahead and move on into story problems. Okay, so when in real life would you ever need to do this? Here's an example. A standard burley box. So let's say that you work at like a shipping company or something, okay? So you have what's called a burley box. It is 5 feet by 3p feet by 4p feet. So the standard burley box is p by 3p by 4p, and it's in feet. A large burley box, so we're going from the standard to the large. What they do is they add 1.5 feet to each dimension. So the dimensions were p, 3p, and 4p. When you go to the large, it's p plus 1.5 feet, 3p plus 1.5 feet, 4p plus 1.5 feet, because they said that they're adding 1.5 to each dimension. They want us to write a polynomial in standard form, so we have to make sure it goes from the highest amount of the exponent to the least, to find the volume. Remember from geometry, your volume of a box is length times height times width. Well, here are my dimensions. So I have p plus 1.5, I have 3p plus 1.5, and I have 4p plus 1.5. So I just need to multiply these together. This is the length, the width, and the height. To find the volume, we just got to multiply those together. Again, you can only multiply 2 things together at a time. I'm not sure what it is, but I always like to do the second and third. It's just a personal preference. You can go in any order. Remember, there's that commutative property of multiplication. Okay, so if I go ahead and take 3 times 4, that would be 12. This has a p, this has a p, so together it's p squared. Now I go over here. If I take 3 times 1.5, I would get 4.5. This has a p, this does not, so together it's 1. Now the middle, if I take 1.5 times 4, you get 6. This does not have a p, this does, so together there's 1. Then when I take 1.5 times 1.5, I get 2.25. The middle two terms can be combined. So again, I want to make sure that I do not forget this first dimension, my p plus 1.5. So I keep rewriting it just so I make sure I don't forget it. 4.5p plus 6p, that's 10.5p plus 2.25. Now I need to distribute one term at a time. P needs to go into 12p squared plus 10.5p plus 2.25. Then 1.5 needs to be brought into 12p squared plus 10.5p plus 2.25. When I distribute a p, I'm just giving every term one additional variable. So 12p squared becomes 12p cubed. 10.5p becomes 10.5p squared. 2.25 becomes 2.25p. Now I'm multiplying every number by 1.5. So if I take 1.5 times 12, I get 18. The variable doesn't change, so it's still p squared. 1.5 times 10.5, that is 15.75. This does not have a p, this does, so together it's 1. 1.5 times 2.25, when I go to the last term, it's 3.375. Now what they want us to do is make sure that we have our final answer in standard form. That's because I only have one variable within the problem. The highest exponent is a cube, so 12p cubed goes first. This term has p squared, this term has p squared. So if I take 10.5 plus 18, I would have 28.5 p squared. This has p, this has p. So 2.25 plus 15.75 is a nice number. We just have 18p plus our constant at the end is 3.375. This is the volume of the large burly box at that box company. Okay, so it's the same skills, but remember when we're dealing with real life situations, it's very common to have numbers that are not so nice. Like here we did end up with some decimals. Now the next one, just because the skills are the same, I think to give you a little bit of time to work on your quick quiz, I am just gonna help you set this up, okay? It's the same process, it's just going to take a little bit longer because the numbers are not so nice, okay? So here's a sample question, real life. Nick manages a manufacturing plant. From 1990 through the year 2005, the number of units produced in thousands can be modeled by this polynomial. The average cost in unit per dollars can be modeled by this polynomial. They want you to write a polynomial, t of x, that can be modeled to figure out the total cost. So what you would have to do are take these two polynomial functions, multiply them together. Okay, that's what they're saying to do. So if I set this up, I would have 0.02x squared plus 0.2x plus 3 times negative 0.004x squared minus 0.1x plus 3. Okay, so this is how you would set this up. Then you would have to take this outside of all of these terms. Then 0.2x outside of all these terms. Then 3 outside of all of these 3 terms. Distribute, combine like terms. Your final answer would have a standard form because you only have x's. But again, if you understood the previous examples, you're good to go. We are not doing this assignment. Remember, you already had done numbers 1 through 8 when we looked at the first part of the video for this section. Your assignment today is to complete a quick quiz. So just a few questions just so I can make sure that you definitely understand what's going on in class at this point. I hope you enjoyed multiplying polynomials with me today, and I'll talk to you soon.